I present you the, our smart platform, which is a Saclay manufacturing and robotics technology platform. I did not know exactly. Oops, sorry. Oops. Okay. I had a few slides at the beginning presenting CEA, but perhaps I can skip them. Just to mention that TERRINet is operated by the technological division of CEA, which is French Atomic Energy Commission, a large research organism in France. Within the technological branch of CEA, we have 3 institutes, 2 in Grenoble, working on micro and nanotechnologies, and also energy and materials, and 1 dedicated to digital systems and robotics near Paris in Saclay. So our aim is to make technological research, applied research. Mainly, our goal is to transfer some discoveries from the research made in universities to the private sector and companies in order to be able to develop new products, mainly in the domains of industry and biomedical and health domain. Once again, TERRINet falls within the scope of the list, which is dedicated to robotics and digital systems. And here are a few figures on list: 700 people, about 80 million euros budget. And one important point, this is why I did not skip completely these slides, is to insist on the fact that compared to academic laboratories or universities, we are highly dedicated to industry and to technology transfer. So we have, considering the list, about 200 industrial customers. And we work mainly for them, more than with universities. You will see it also with figures on the robotics lab. Another important message is that TERRINet is in fact part of a larger initiative that we have in Saclay, which is DigiAll, which is the Paris region digital innovation hub. Which focuses on different aspects, not only robotics, but also artificial intelligence, cyber physical systems, cyber security with different applications. And this initiative builds on some strengths of Ile-de-France region in France, which has a large part of research and development in France. With infrastructures, a rich ecosystem. And DigiAll aims at leading local clusters with a lot of different initiatives from local universities, local engineering schools, local research centers, and dissemination and exploitation structures. And it also merges different European initiatives, of course TERRINet, but also digital innovation hubs in healthcare domain, in inspection and maintenance, agro, robo-food, also in artificial intelligence. And this allows us to offer a lot of services for our friend companies that we support, and especially regarding it's more oriented towards companies, but what falls within the scope of TERRINet is still collaborative research and development, living labs, test beds, pilot lines, and coming back to robotics, after this very short introduction to CEA and LIST, TERRINet is operated by the Interactive Robotics Laboratory, which is a team which is composed slightly differently from, once again, industrial laboratories. We have more permanent people than PhDs. And our expertise is specifically dedicated to robotics, covering every aspect from mechanical design to electronics, real-time software control, And our aim is to develop systems as operational as possible, and to prototype them and to install them as much as possible in industrial contexts in order to be able to test these robots on site. As you can see, regarding resources, more than half of our budget comes from industrial contracts. Only 15% of our budget comes from money from the direct money from French state. And this explains also that we are as much active in patenting as in publications. So from a historical perspective, we come from, as we are part of CEA, we come from a nuclear industry, nuclear context. So from a long time, we developed systems dedicated to remote handling and manipulation of radioactive materials. In the 60s and 70s, we first developed mechanical systems. Then with the advent of robotics and computer science, we were able to separate master and slave arm and introduce some assistances, which allowed some use in real nuclear power plants. In La Hague, for example, we have some robots that are operating there. As you can see, it was a long time between research and development and use in real nuclear plants. And then we were able to have some diversification in our applications. Our systems being now utilized in several domains. And with a focus for the future on also artificial intelligence and making our robots more and more autonomous. One important point is that as we come from purely mechanical systems, most of our systems, almost all, are highly backdrivable. That means that we can make position control, of course, but also force control, impedance control without force sensors. Systems are sufficiently backdrivable to be able to have some force measurement and control using only the current flowing through the motors of the robots. Also, our ecosystem is composed of research centers and organizations, but also companies covering both end users, like large companies, car companies, Airbus, and so on. And what is important for us to also have technological providers, which are the companies to which we can transfer our developments. Our robots, the basic idea is to develop some new systems, some new technology within either directly for some industrial customers or within some collaborative projects. These systems are dedicated to fulfill the requirements of the end users, but we need techno providers in order to be able to industrialize our robots and sell these robots to the end users. So, smart platform. In fact, it belongs to a larger network of infrastructures. Smart platform is located in Saclay. It's all kind of it's not specifically dedicated to one kind of industrial robotics. And we have some other platforms in different cities in France, which are associated to the smart platform. The first one is Florian in Tremory. It's a specific platform in the sense that it's located inside Peugeot Citroën car factory. It's some kind of test bed for robotics solution, industry for 4.0, IoT, and so on. It's already inside the PSA factory. We have another platform which is CleanAtech in Grenoble, which is dedicated to medical assistance with development of exoskeletons and BCI controlled systems. We have another platform in Nantes, which with mostly virtual reality simulation tools in order to be able to test some assistances. And another platform in Bordeaux, which is dedicated to telerobotics, plus a new one in Cadarache for ITER, so which is a fusion reactor, developed international fusion reactor, which is located in Cadarache, and for which we want to develop maintenance robotics. All these platforms offer physical infrastructures with robots and sensors and so on, but also some software framework and some infrastructures, network infrastructure. Now, coming back to TERRINet. On the website, we described some systems. This is a snapshot of the TERRINet website. What we can see is that we propose assistive devices, collaborative robots, telerobotics and haptics and exoskeletons solutions. And what we, in fact, what I wanted to tell you is that some of these systems are already provided by companies. So these are industrial products. Some others are prototypes. Some are still functional. Some other are historical developments. And I think it is important to give you a better picture of what is really usable and what can be offered to visitors. So first of all, what we can offer is a force feedback remote handling system, which is available in Saclay on the Smart platform. It's composed of Aption Virtuos Master Arm, 6 degrees of freedom, with a range of motion of the arm, about 1 meter. It allows to control remotely different kinds of robots. One of them being the Stobli TX90. In order to be able to couple both robots together, we use the Cortex software, which was developed by CEA. It's the last generation of computer-assisted téléopération controller. TAO is a téléopération assistée par ordinateur, computer-assisted téléopération, computer-assisted remote handling. It allows to use any kind of master arm, any kind of slave arm with Cartesian space coupling with possible force or position amplification or reduction, some clutching functions. And it's associated with SCORE, which is a supervision tool in which you have a digital twin of the robot and environment in which you can make you can implement virtual guides or which are trajectories you are forced to follow, generated by a virtual mechanism, or you can implement repulsive areas in order to avoid entering some dangerous zones or avoiding to damage environment. So the Stobli can be controlled in teleoperation. It can be also used as a standalone system. We have also an ABB robot, and these are commercial systems. And we developed within a European project Romance 3 finger gripper. It's underactuated with 4 motors and I think 9 or 10 degrees of freedom. It's quite large system. Allowing to grasp objects of the size of my forearm, about. Regarding collaborative robots, we have several systems available also on site, some of them being already mentioned on the TERRINet website, some not. So we have several prototypes. EasyBot is a new spin-off that we launched 2 years ago, I think. This was the prototype of their robot, and this is the product that they sell now. So of course the product is operational. The prototype is less. It can be used, but it's less robust. We have also a big SCARA robot, which was developed to carry heavy boxes in the agro-food industry. So the range of motion is several meters, and the capability about 60 to 80 kilograms. It's a force amplification system that you can program also by demonstration in order to displace these boxes automatically. These are videos. I will perhaps skip part of them. So they don't run. So it was examples of use of the collaborative robots. Perhaps this one will work. I don't know. So it doesn't run. So it was an illustration of the use of these robots to for sanding and polishing operation on cars, trains, and so on, which are at the heart of the business model of EasyBot. Regarding cobotics, we have several systems also, some of them being still operational, some of them being historical and no more operational, some of them being in between. So regarding force amplification system, we developed in the past this robot with company RB3D. It's a system that was developed to for example, for the foundry industries, in order to be able to help operators carry EV tools that vibrate a lot or that produce large forces and that are difficult to manipulate. The idea being to that for such systems, this category of systems covers systems that are in permanent contact with the user in order to amplify the user's force or to guide his movements. And so we have force amplification system, we have intelligent manipulators, and we have also exoskeletons falling within this category. Regarding intelligent manipulators, we have this CoboManip system, which is a robot that was developed for tool handling assistance. It's available on the smart platform. It's so the size. This part is about the size of a man. You can see it here. It's slightly larger than on these pictures. So the workspace of the robot is 5 to 6 meters, in the horizontal direction, and it can lift object up to 120 kilograms. The idea is to allow manipulating heavy objects as if these objects were in a zero gravity area, and also with some assistances based on virtual guides and protective areas in order to protect the environment. This robot is coupled to a digital twin in order to be able to implement some of these functionalities. And finally, regarding exoskeletons, we have different kind of exoskeletons that were developed in the laboratory. Some of them for lower limbs, some for upper limbs. Regarding the legs, this is Exoslim, which is a prototype under development. It was emphasized on the website, but it's still not fully operational. With RB3D, we also developed more operational systems that are now sold. but which are very simplified compared to exoskeleton. These are very dedicated systems in order to help operators make a particular task on site. This was developed for the construction domains and road buildings, road construction. And regarding the upper limb, we developed some systems for the arm. Able system is now sold by Aption. We have one of such system, which is the first prototype. It's still operational. It can be used at CEA. And we also worked in the past on hand exoskeleton. Which are unfortunately not fully operational as these prototypes were developed within collaborative projects, which are no more funded, so we don't have sufficient money to have them operational for a long time. Regarding software, basically this is an illustration for teleoperation, but this architecture also holds for collaborative robotics. We basically use two kinds of software. The first one is Cortex, which is a real-time controller allowing to couple, as I told you before, different kinds of master and slave arms with advanced functions. It's modular. It's a modular architecture coded in C++. And it is associated with SCORE software, which is a 3D supervision tool, allowing to implement digital twin of the robot with the dynamic simulation. It runs also another tool that was developed by another laboratory, which works on interactive simulation. And they developed some specific code in order to have a physically realistic simulation in real time, in order to be able to simulate virtual reality a situation in virtual reality in real time for training, for operational rehearsal. And it allows to have haptics in the simulation, which means it runs at several hundred of hertz. And SCORE also allows to implement programming by demonstration functionalities and programming also on using the digital twin or the real system with some visual servoing. And my last slide, I think, is dedicated to this kind of commercial systems that are emphasized on the website, on the TERRInet website also, but are physically not present in Saclay. They are present in the regional platforms that I presented at the beginning of my introduction to CEA and LIST. And those systems are in Tremory, in Flor. So it's possibly accessible, but it's more difficult than the systems that we have on site in Saclay. That's all. Thank you for your attention. Yes, in fact, we try to answer the needs of industries, but one of our missions is to support first French industries and European industries and world industry. So this is the order of in our mission. This is the order that we have to respect. Still, we have some requirements from US companies, Asian or European. It depends on.
you have so many machines that are close to the needs of industry in many applications. So I don't know, Rosella, you remember how many applications there were to CEA?
That is called?
From the beginning?
From the beginning, I believe 2 applications.
Okay.
I mean, users accessing CEA.
Okay.
I don't remember if there were more applications and then rejected, but for sure at least 2 users.
Coming not from industry, do you remember now?
No.
Not necessarily, no.
Because I think that you are really in a position where you
Yes, because
access from
Well,
industry.
you as RIF, okay, you are in contact with SMEs because you also were involved in ePort++ project, so maybe they could really help industrial users.
Yeah.
But so far,
Okay. So
this kind of contact does not necessarily come through TERRInet. We are also involved in ESMERA, Cover, and the IH. Mm.
framework of TERRInet,
Mm.
because yeah, we need some, and you are in a very good position for so if you can have an incentive
Mm.
grow, it's
Probably from the beginning of the project, we did not advertise sufficiently,
yeah.
specifically on TERRInet.
Because we discussed a lot about that, as Christophe didn't attend the meeting, I make you aware that
Mm.
we need this communication, and in particular with industry, we have few applications. So it would be nice if you already have contact with European companies that plan to test some of your machine to come for a few days, and that you then appear in the framework of TERRInet.
Yeah, I have to check once again the different advantages that we can propose through TERRInet, through the other project. There are some cascade funding through different projects with different kind of consortiums that can apply with different budgets and so.
You have question?
Just curiosity, how can you deal with, I saw like 40 projects per year with 50 people working?
It's quite difficult. It's one of the reasons why we did not have sufficient time to advertise each project, and so it's quite difficult. So some projects are quite are small projects. For example, we develop a specific tool for an industrial customer with a budget of a few tens of kilo euros and 3 to 6 months. These are short projects. We have joint labs, not necessarily. For example, on exoskeletons, we had a joint lab with RB3D running for several years. In between, we have the European projects. We have some French project. It depends.
But I mean, those 50 people are working together with other, I mean, researcher or engineer in the university or in the industry in order to grow the number of people working on the project? Is really
within so in the past, so the pressure is higher and higher with years. In fact, unfortunately, in in the past years, we had more European projects, French-funded collaborative project, which allowed us to have more connections with outside researchers. Still, we try now to, as most of our budget and projects come from industrial contracts, we work more with industrial partners. Depending on the project, either we develop entirely on our side some prototypes or answers to their needs, or depending on the project, we work with them. We propose some ideas that they implement. It depends. Thank you.